Okay, we are recording. Cool. All right, so we didn't get too far into this on Monday, but so I'll kind of recap a little bit. I won't bother going over the learning objectives again, but I will start right after the learning objectives. So uh, this chapter again is all about deriving the demand for healthcare or medical care. And we start with our utility function, right? So that's kind of our starting point, is the utility function. And recall that we are assuming that people get utility directly from consumption goods and their health. And of course, there is no disputing of tastes, right, when it comes to preferences. So, and then remember that we are going to assume that the consumer's utility function is stable over time, so it's not changing in any way. Um, but this is an assumption. It's totally possible that people's preferences change over time. In fact, that's probably the more realistic scenario. But that would make this analysis pretty much almost impossible, right? So this is almost a necessity. We almost have to assume that they are stable. Otherwise, it just gets very, very, very complicated. But that's not a problem. It still provides us with a host of useful insights, right, that are useful. And so what we were doing here is we're basically just taking the usual standard consumer theory approach. We're assuming that consumers are trying to make themselves as best off as possible, or in other words, maximize their utility, or in other words, reach the highest indifference curve, right? Because we're going to start our approach by looking at indifference curves. But of course, this process is limited by the consumer's budget or income. So far, this is all standard stuff, right? Normal consumer choice theory. But there is one major difference here, and that's that we cannot purchase health directly like we can purchase whatever is in X, right? Clothing, food, right? All that stuff that's in X, we can buy, right? That's normal. But we can't buy health directly. But what we can buy is medical care, and then that translates into health, right? So that's really the major difference here between sort of the traditional consumer choice theory approach and what we're doing here in the choice for medical care. And of course, we have this production process that allows us to translate medical care into health, right? So that's what provides us with the connection. And just some things to remember here or to keep in mind. This production process is almost certainly subject to diminishing marginal returns to scale. So the more healthcare or the more medical care we purchase, the less of an effect it has on health. And so sort of a shorthand way of thinking about this relationship is the first derivative of the production function, right? That's what G prime M stands for. It's the first derivative. Another way of thinking about it is it's the marginal productivity, right? The rate at which a small health improves for a small change in medical care. But this is important, right? Because this relationship between health and medical care is what allows us to sort of translate indifference curves in the health and consumption space to the medical care and consumption space. So you'll see what I mean in a minute when we look at these figures. Now, if it were the case that the marginal productivity of medical care was constant, then both of these charts would be identical, or at least the indifference curves would be identical. Well, as well, I guess the budget constraint and PPF would be identical as well, actually. But they're not. There's a diminishing marginal return, which means that our PPF in figure A here is curved, right? So the reason for that is the diminishing marginal returns of medical care. And so typically, right, when we're looking at indifference curves, we just have the things on the axes. There we go. The things on the axes are the things that directly affect our utility. So typically we would look at just what we have in figure A. But then, of course, like we mentioned earlier, the problem is that we cannot purchase health directly. We have to purchase medical care, and that is transformed into health. So what we really want to have on our axes are things that we can purchase. And so we have to make this transformation from figure A to figure B. And so basically what we're looking at here are, a couple of indifference curves, which basically they both represent the same level of utility, right? U1 on the left is the same level of utility as U1 on the right side, right, of the figure. The only difference is that these indifference curves have basically been transformed by the production function, right? H equals G of M. And so one way of thinking of this transformation is if you drew figure A on like a rubber sheet, the production function for health is stretching that in different ways to arrive at what we see in B. And it's stretched in such a way that the PPF becomes a straight line and ultimately becomes the budget constraint. Okay, so that's a very crude way of thinking about what's going on, right? Is this sort of stretching and manipulating figure A to transform it into figure B. So some things to think about here, right? So that's basically what I just talked about in terms of stretching, okay? So the other thing to recall here is that the stretching that takes place, since it depends on the production function, also depends on the type of illness and its severity, okay? Because remember that the production function for health is conditional, or in other words, depends on the type of illness and its severity, okay? So that's also something to keep in mind here. So the picture that we saw here, let me go forward instead of backward. The picture that we see here, whoops, no, I guess I do have to go backward. The picture that we see here in B is assuming a particular production function and therefore a particular illness and a particular severity of that illness. If the illness was different or the severity of the illness was different, then the transformation from A to B would look different. Okay. And you'll see what I mean in a minute because we'll take a look at an example of that. All right. So again, to reiterate, we're assuming that consumers want to maximize their utility within the constraints of their budget. And I've given the mathematical formulation of this problem, right? The problem is to maximize utility by choosing a combination of X and M such that the consumer is within their budget, right? The price of X times the amount of X plus the price of medical care times the amount of medical care is less than the total income that less than or equal to the total income the consumer has, right? So that's the maximization problem. And since consumers are trying to maximize their utility, we also assume that they spend all of their money, right? So it's not just an inequality, it's actually an equality, right? The amount of money the amount of money they spend on X and M is exactly equal to their income. So that's what we're doing here, right? And so once we have this set up with the indifference curves, we can begin to think about what happens in the event of an illness, right? What happens when a consumer gets sick? All right, so to see this, we're going to look at figure 4.2. And I want you guys to first focus on the left side, right? Figure A. So there's a couple of effects of this illness. The first effect is that there's a decrease in health from H0 to H1, keeping consumption constant, right? So the consumption of X is held constant. So that's the first effect. The second effect is that the illness reduces the production possibilities of both H and X. And so once this happens, the consumer is going to kind of shift their consumption, right? They're gonna reduce their consumption of X and boost their health from H1 to H2 by consuming some medical care. So we don't see the medical care in figure A, but we do see it in figure B. So now shifting over to figure B, what we're seeing is that the illness, right? The illness affects the production function, and the production function is what is stretching A to create figure B. And so that's why we see two different sets of indifference curves. We see the bold indifference curves where there is no illness, and then those indifference curves basically, let's see if I can do this right. Nope, the other way. Yeah. Yes, the indifference curves get flatter as a result of the illness. Okay. And again, that's because the illness affects the production function, which affects the stretching. Okay. So again, what we need to keep in mind is that the utility function is stable. So nothing about the indifference curves is changing in A, but they will look different in B because of the stretching that's involved because of the production function. Okay. And we can see that when those indifference curves in figure B become flatter, it's going to imply that there's going to be a shift in consumption, right? Less X, and more medical care, right? Which makes intuitive sense, right? When you get sick, you spend more money on medical care, and if you spend more money on medical care, you have to spend less on consuming other things. So hopefully, that should make sense intuitively, right? Okay, so what we saw is that the illness causes a loss of health, which we could call L. That's the change in health, dropping from H0 to H1. So we saw that. And then we also saw that the illness reduces the set of possible combinations of X and H. That was a shifting in of the production possibilities frontier. And keep in mind that the shape of the PPF depends on the production function, and the curvature of it relates to the diminishing marginal returns of medical care and producing health. So we already talked about that. And what we see, right, the result of this illness is that the consumer gives up some X in order to buy some medical care and recover some health, taking them from H1 to H2, right? So just to take one more look at that, that's what we're seeing here, okay? And keep in mind that the subscripts and the numbers don't correspond with levels of utility. It has to do with the sequence of events, right? So we start with U1, the illness drops the consumer to U2, and then they shift their consumption away from X and towards medical care to recover some health and end up at U3, okay? All right. Now, so far, we are assuming that there's no effect of the illness on income. It doesn't impact the consumer's income, but that's totally a possibility, right? If you're sick, especially if you work like an hourly wage job and not a salary job where maybe you get sick days or something, it definitely can have an impact on your earnings, right? Oh yeah, I need to mention these things first before moving on. So I already mentioned this, right? The utility function is stable, but it appears unstable in figure B because of the stretching involved, right, through the production function. And so that translation through the production function results in changes in preferences over X and M, right, over the preferences over X and medical care, but not over X and H, right? That's the stable relationship there. So ultimately, the illness causes there to be an increase in medical care consumed and a decrease in X consumed. That's basically a recap. But now we want to think about what if this illness also causes a decrease in income, right? Well, in this case, then we have one other change, and that's that the budget constraint shifts inward, right? And we can see this in figure 4.2c. And so what we're going to see in that figure is that there's still an increase in medical care, right? The amount of medical care consumed still goes up in this case, but the levels of medical care and X consumed are lower than in the case where income doesn't change. Okay, so we'll see that right now. So here, looking at the original budget constraint, right, the one that is higher, we have U1, which is the utility without illness, and then the two thinner indifference curves. The one that's higher is the consumption bundle, tells us about the consumption bundle if there was no change in income, right? So those are basically taken from figure B that we saw earlier. But now we're assuming that the illness also causes a decrease in income, and so the budget constraint shifts in, and the consumer ultimately ends up at basically 0.3, where they're consuming X3 and M3. And so we can see that compared to no illness, right, M1 and X1, medical care has gone up, although not as much as it would have if income didn't decrease. And on top of that, the consumption of X is further reduced from X2 to X3, which makes sense, right? But we're assuming that M and X are normal goods. And so if this person's income declines, we would expect that the consumption of X and M also declines. Okay, so this is how we can use indifference curves to analyze the effects of an illness, are in these ways. But it's important to keep in mind that there are potentially many pathways to affecting health and medical care consumption, right? So what we're doing there is that we're assuming that the only thing changing is income, and that nothing else related to income might be changing. We're holding those other things constant. And so we can think a little bit further about what would happen as, say, income increases, assuming everything else stays the same. And when we do that, we get something that looks like figure 4.3, which is going to illustrate something called expansion paths. All right, so what we're seeing here is basically the same picture we saw earlier, but now with income increasing, right? So in figure A, when income increases, it increases the production possibilities for H and X, for health and consumption goods. And if the consumer goes through the same maximization process, they're going to find the highest indifference curve that they can achieve given their production possibilities. And if we plot a line or a curve along all those maximization points, we basically get what's called an expansion path, right? It's basically telling us that as the production possibilities increase, what is the path that the consumer takes in terms of the consumption of health and consumer goods. And we can do the same thing in figure B, right? As income expands, you need to remember to do this in the opposite direction. I wonder if I can mirror, hold on one sec. I'm gonna mirror my my video here. There we go, this will help me. Yes, as income increases, right, the consumer is going to continue to find new combinations that maximize their utility, and if we plot those points, that gives us an expansion path of consumption. How does their consumption expand as income increases, right? So this is a nice way of thinking about the effect of just income, right? No other related effects. And we can kind of take this one step further. If we plot the levels of income against the levels of H and M that we see in the last figure, we basically get what are called Engel curves for H and M. And that's what we see in figure 4.4 here. So here we have angle curves, right? So the x-axis is income, right? That's the independent variable, and it's determining health in A and medical care spending in B. And so, not surprisingly, there's a positive relationship there that we can see with the solid line. And that's because, of course, these things are normal goods, right? As we make more money, we consume more of these things because of we're assuming that they're normal goods. So that's what we see with the solid line there, given by the pure income effect. But then, like we mentioned, there are lots of pathways that income can affect these things that are sort of secondary. And so that's what we see with these dotted lines here. So the first one I want you to look at is the one in figure A labeled sanitation effect. So it could be that at very low levels of income, basic sanitation needs like toiletries, toothbrushes, vaccines have a very large impact on health. Okay. And so that's something that we're kind of ignoring here, is that maybe at low levels of income, there are basic needs that have a high impact on health, right? So in that case, if that was true, then our angle curve for health would kind of follow this initial dotted line labeled sanitation effect, right? And then on the other side, we see some other effects from high income, right, at the high income range, and so really, if we're thinking about this, it has to do with the fact that at high levels of income, people might consume things that are bad for them, right? So remember from the last chapter, there was a weird exception, right, to the relationship between income and health, and that exception was for white men. And when white men make higher incomes, for some reason their health deteriorates, and the theory there was that, well, they must be consuming more XB, right? Consumer things that are bad for health. And so that would be what the book calls living in the fast lane, right? The effects of living in the fast lane. And so in that case, we can actually get a negatively sloped angle curve, right? At high levels of income, if people consume more things that are bad for their health, then we can actually have a negative effect of income on health. So this relates directly back to our discussion of the relationship between income and health. But we could also imagine like an opposite effect, right? If you have more income, then you can go to the spa, you can go to the chiropractor, you can buy organic food and eat more healthy. So that would have the opposite effect, right? That would be what we would call maybe the health spa effects of income, which would sort of increase health, right? As our income goes up. And there's lots more potentially complex relationships between income and health that we aren't looking at here, right? Those are just some examples. Um, but the solid line does give us the pure income effect, right? Ignoring other possible changes. All right. Any questions so far? Feel like we're flying here. Okay. So like I said, figure 4 is showing us some, but not all of the complications arising from changes in income. The sanitation effect was this idea that for low levels of income, basic sanitary needs may rapidly improve health. Life in the fast lane could imply a negatively sloped angle curve, meaning that as income increases, health actually decreases. So, think of the white men exception that we talked about in chapter 3 or 2. Can't remember which one. So the life in the fast lane, that's the white guys losing health when they're richer. But then there also could be this maybe sort of health spa effect where you're able to purchase things that are good for your health when you make more money, right? Okay, so that's what we were looking at here. All right, so if there's no questions, we're going to take the next step here, right? So now we're going to take the next step, go from indifference curves to demand curves. So the major problem with looking at indifference curves is that they are unobservable. We cannot measure people's utility, and therefore we cannot measure or observe their indifference curves. But what we can potentially observe is their demand curves, and we can derive their demand curves from indifference curves. And so we can actually backwards induce, if we can observe their demand, we can backwards induce to their indifference curves if we can observe their demand. So the approach we're going to use here is using our indifference curve map, change price. We're going to change the price of medical care, and that will effectively change the budget constraint by rotating it. And once we change the price of medical care, we can look at how the change in the budget constraint, the rotation of the budget constraint, changes the consumption of medical care. And keep in mind that, you know, we've got a ceteris paribus assumption here. We're holding income constant, we're holding illness level constant, and we're holding the price of X constant. And then once we do that, we can plot the different prices of M against the various resulting levels of medical care. So that's the approach we're taking. All right, so here we go. On the left, we have our indifference curves and budget constraints at two different prices of M. And then on the left, or rather on the right, we have the resulting demand curve. All right, so basically what we're doing here is we're changing the price of medical care from PM1, a high price of medical care, to a lower price of medical care. So the effect of that is to rotate the budget constraint sort of clockwise, I guess, right? Because a lower price of medical care means that you can afford more medical care, right? So it rotates the budget constraint clockwise. And if it's helpful, you can just think about the medical care intercept, right? When prices are high, the maximum amount of medical care is constrained, but as medical care becomes cheaper, the maximum amount of medical care increases because it's becoming cheaper, and so that's why it's rotating clockwise. And that clockwise rotation is going to mean that the consumer is going to choose a different combination of X and M as medical care becomes cheaper. And so that's what we're seeing here. Now, the interesting thing, I guess, here to note is that as medical care becomes cheaper, this consumer actually ends up consuming less X, which doesn't have to be the case. It could be that medical care becomes cheaper, and not only do they consume more medical care, but maybe they also consume more X. But in this case, we're basically being told here that these things are substitutes, right? Medical care and X are substitutes, but that doesn't have to be the case. It could be that they're complements. So just keep that in mind. It's not that important at this point, but something to be aware of. But basically, right, we've changed the price of medical care, and it results in a change in the consumption of medical care. And if we plot those two things together, P1 with M1 and P2 with M2, then we can construct a demand curve like we see in figure B. Okay, so we've only done two points, so we could just draw a line between those 2 points and say that that's our demand curve. But if we wanted to be thorough, we would basically continuously change price and track the continuous changes in medical care consumption. And that would give us the demand curve that we see here. Okay. And the other thing to keep in mind, right, is that this is the demand given a specific income and a specific illness. Okay. If the income is different, or if the illness is different, the demand curve is going to look different. Primarily because the indifference curves in A would be different, right? Well, the illness would change. A different illness would give us different indifference curves. A different income would give us different budget constraints. Right? And so thinking about the effect of income, right? Well, we're going to assume that medical care is a normal good, and so more income means a higher demand, right? So that's one way to think about, you know, if we didn't hold income constant, how would it change demand? Well, it would change in this way. Higher incomes mean higher demand, right? A shift to the right. Any questions about this process of deriving demand curves from indifference curves? Everybody's good? Okay. So in addition to thinking about how income would affect demand, we can also think about the effect of different illnesses, right? How does the demand curve depend on different illness events? Um, and the theory that we've built so far gives us a pretty common sense result in that sicker people will demand more medical care. Okay, so this result is built into the theory we've built. Um, and if we were to go through a formal mathematical proof, it would be pretty messy. But we can illustrate the main idea of this, and we actually already saw this main idea in Figure 4.2. And the way that we can think about this is that bigger illness events, or in other words, things that cause a greater loss of health, cause the indifference curves in 4.2b to become even flatter, which technically means the marginal rate of substitution becomes bigger. Um, and therefore the resulting choice of M is higher. Okay, so going back to 4.2. Okay, so the illness, the loss of health, the illness event causes the indifference curves in B to become flatter. And the bigger that loss of health is, the flatter they become. And as they become flatter, the amount of medical care increases. Okay, so that's a nice intuitive result, right? Sicker people demand more health care or more medical care. And so if we were to plot these various demand curves given various illnesses, it would look something like this. Uh, Obviously, the demand for healthcare with normal health would be the lowest demand. And as the illness increases in severity, the demand for healthcare would shift to the right. And not only would it shift to the right, but it also might become steeper, right? And what does that mean? What if the demand curve becomes steeper? How do we interpret that, or what's the good way of thinking about that?
Is it becoming more inelastic?
Yeah, exactly. Good job, Bella. Yeah, so not only is demand increasing, but it's also becoming more inelastic, right? So you can imagine um, needing a heart transplant, right? That's a very serious illness, and you're pretty much perfectly inelastic with that type of treatment, right? You need a heart, and you either get it or you die. So that's pretty much perfectly inelastic there. so so think about that too, right? Think about the elasticity relating to illness. Um, Now, so far, we've kind of assumed that there's just one type of medical care to consume, right? But we need to keep in mind that there's a complex array of medical services available, not just one vanilla flavored medical care, right? Um, so, including this, right, making the model a little bit more realistic in this sense, makes the theory a little more complicated, but the process is basically the same with a couple of minor adjustments. Okay. And those minor adjustments are recognizing the fact that one, health can be affected by more than one type of medical care. We've kind of already mentioned that one actually in this discussion. But okay, so the way to think about that in terms of the production function is that health is a function of various types of medical care, right? M1, M2 to M, M, M script N, right? So if there's n number of medical services, this is what the production function would look like. So that's kind of the first change or the first adjustment. The second adjustment that we need is to be able to recognize that these various types of medical care can either be complements or they can be substitutes, right? So some medical procedures or treatments are complementary, right? So um, getting what was it called? A cabbage, right? A coronary artery bypass graft or whatever it was. So maybe doing that and then also eating less red meat. You could consider that to be a medical treatment, right? Those are complementary, right? But a cabbage and a I can't remember the other one. So these are the two procedures that Boston and New Haven medical schools used, right? They had differences in rates of use. I think New Haven used the cabbage, and then Boston used the other one. Those are substitutes, right? So that's the kind of way that we're thinking about this in those terms, right? And just if you need, well, let's see what I have here. So basically, the result of these adjustments give us a couple of results. Um, the first is that each type of medical care is going to have the demand for each type of medical care is going to depend on the each type of medical care's marginal productivity, right? Um, and so people are going to demand procedures with a higher level of marginal productivity first. And then, of course, as they consume that treatment, the marginal productivity is going to diminish. And so they might start, at that point, they might start consuming other types of treatment. But it's all going to depend on marginal productivity. And therefore, ultimately, each type of medical care is going to have its own demand curve. Now, thinking about complements and substitutes a little bit more, this is really hopefully some review. You should have learned this previously, but so just to review these things, right? Complements are things where if the price of one of them goes up, the demand for the other falls, right? So if you want to think about a very simple complement, a pair of complements, think peanut butter and jelly, right? If peanut butter gets more expensive, you buy less of it. And if you have less peanut butter, you don't need as much jelly, right? And on top of that, your real income has fallen. And so you can afford less jelly additionally, right? There's both the income effect and the substitution effect going on. Whereas with substitutes like Coke and Pepsi, right? If Coke gets more expensive, then you demand more Pepsi, right? So hopefully these things are review. But there's a reminder for you in case you forgot. And so some questions regarding medical care are things like, are hospital care and ambulatory care complements, or are they substitutes? And this is something we're going to look at in the next chapter when we get to the evidence part. So, that's a really good question. You might think to some degree they're complements, right? When you when you get a ride in an ambulance, where do they take you? They take you to the hospital. So those seem to be complements. But it could be that while you're in the ambulance, you get sufficient care, and so when you get to the hospital, you're like, actually, no, I'm good. Like the paramedics took care of me. I'm out, right? In which case, they're substitutes. And honestly, there's probably a little bit of both going on, right? So, you know, as with most goods, there's elements of complementarity and substitutability, except for in the case of perfect complements and perfect substitutes, right? Um, but for the most part, and actually, right, that's actually why indifference curves are typically curved, is because there's complementarity and substitutability at the same time. It's only when, I don't know if you guys remember this, but perfect complements have an L-shaped indifference curve, and perfect substitutes have a straight indifference curve. So, um, except for those in those extreme cases, right, we get curved indifference curves, and that's because there's complementarity and substitutability at the same time. So that's probably true of hospital care and ambulatory care. I guess the question then is which one dominates, right? Which one is dominant? Another question might be, are preventive care and acute medical care complements or substitutes? And this one isn't exactly clear and straightforward either. If you're taking actions to prevent things like heart attack or cancer or stroke, then obviously you're not going to need um, invasive surgeries, right? So in that sense, it seems like these things are substitutes, but they could go together, right? And I think to a large degree, this depends on the type of medical care, right? Preventive care is going to be a substitute for heart surgery, but it might be a complement for routine physicals, right? It just depends, right? And we're going to take a look at these things in chapter 5. But something to think about is that the answers to these questions are going to have profound effects on how insurance is designed, right? Because if, let's say, preventive care and acute medical care are substitutes, well, then it's going to be beneficial to insurance companies to incentivize preventive care, right? Because that's cheap. Preventive care is cheap. Just eat healthy and exercise a little bit here and there. And then we won't have to pay for your heart surgery later on, right? And so, the answer, like I said, the answers to these questions are going to have a real impact on how insurance is designed. And we'll look at that in later chapters. All right. Any questions so far? Okay. One other thing we need to think about while we're on the topic of demand is, thinking about how we come up with an aggregate demand curve or a demand curve for all of society, right? And this should be hopefully a review for you as well. But we basically just add up individual demand curves, and so that's what we see here. We have an aggregate demand curve for 3 people, a 3-person society. So let's see, D1, D2, and D3 are different people, demand curves for different people. And we're basically just adding these up along the horizontal axis, right? So we're adding up the quantities at each price. And that's where the kinks, the bends or the kinks in the total demand curve are coming from. So between the price P3 and P2, I don't know if you guys can see, let me get my laser pointer out here. So between the price of P3 and P2, there's only one consumer demanding medical care. But as soon as price drops to P2, we now have 2 people demanding medical care. And so we have a kink there at P2. And then it isn't until P1 that a 3rd person basically joins the market. And that's why there's a kink at P1, right? Is because at that point, now the last person joins the market at prices below P1. So that's where the kinks are coming from. And that's why we get that's why we call them demand curves, actually, because in reality, they are curved for this reason. Right. Although they can be curved for individuals too. They don't have to be straight necessarily, but even if they are straight for individuals, the total demand curve will end up having a curved shape. All right. So we don't need to spend much time on that. Now, the nice thing about demand curves is that we can use them to measure the value of care, right? Demand curves are illustrating basically the marginal value to society or the marginal value to an individual if we're looking at individual demand curves. And when we think about demand in this way, it's really giving us sort of a willingness to pay interpretation, right? We're thinking about it in terms of willingness to pay. And if your willingness to pay is higher than what you actually pay, well, then that difference is your consumer surplus, right? And so, what we have been doing so far is saying that price determines quantity, but we can just as easily say that given a particular quantity, that tells us the value of that quantity to society, right? The marginal value, which ultimately is price. So, basically what we're doing is we're inverting the demand curve to create what are called value curves. So we're just switching the axes essentially. But I don't even know, like I've actually never seen the actual graph inverted. We're really just thinking about it inversely. I've never seen any book or textbook or professor actually switch the axes, but that's essentially what we're doing. And there are 2 main reasons why these inverse demand curves also are downward sloping. The first is that there is a declining marginal productivity of medical care. So that's one reason. As we consume more medical care, it has less of an effect on health. And because it has less of an effect on health, we should be willing to pay less for additional amounts of medical care. We're not getting as much bang for our buck, in other words, as we consume more. And also, there's the decreasing marginal utility of health, right? So as our health improves, it provides us with less and less utility. So both of those things are contributing to the downward slope of the inverse demand curve. Um, and it's interesting to note that 1.1 by itself is sufficient to create a downward sloping demand curve. We don't need to have diminishing marginal utility of health. We just need diminishing marginal productivity of medical care. But adding diminishing marginal utility of health just further adds to this downward slope. Right. And so we can extend this idea to noting the total value rather than just the marginal value. So we were talking about marginal value, but we can add these marginals up to get total, right? And this is, hopefully this is review too, because basically what we're talking about is consumer surplus, right? The total value to a consumer or to society is represented as the area below the demand curve and above price. I should have added that too, but right, this is just consumer surplus. So let's take a look at figure 4.8 as an illustration of this. So I imagine this is for an individual, right? A single consumer. And so, this doesn't look like a demand curve, but it basically is, right? It's basically saying that this person's willingness to pay for their first dental visit in a year is $100. Their willingness to pay for a second dental visit in a year is 75, right? And so that's basically, if we were to draw a line between the tops of those bars, we would have a demand curve. And here we're looking at a cost per visit of $30. And so there's a couple things that we can take away from this. The first is that this person only consumes a dental visit as long as the willingness to pay is above the cost of the visit. And so in this case, this person would consume 3 dental visits per year. The 4th dental visit isn't worth it to them, right? So that's the first thing to note. The other thing to note is we can figure out the total consumer surplus by adding up the areas that are shaded here, right? So the consumer surplus from the first unit is 100 minus 30, and so the consumer is getting $70 of value from that first visit. They're getting $45 of value from the second visit, and they're getting $5 of value from the third. You add all those up, and you get their total consumer surplus from consuming 3 units, 3 dental visits, right? So that's what I just mentioned there. And then I guess another thing to note is that, well, I already mentioned this too, but the surplus is maximized when, this person expands the use of this service until marginal cost either equals marginal value or to the point just before marginal value drops below marginal cost, which is what we saw there. Because they never actually equaled each other, right? Because we live in a world where people consume discrete values, right? You can't consume half of a dental visit in the real world, right? If you could, then at some point the marginal cost would exactly equal the marginal benefit, but we live in a world where you can only consume whole numbers of things. So that's kind of interesting, but it's a pretty simple rule, right? Only consume it up until the point where it's no longer worth it, is basically the gist of it, right? So that's what we saw. And we can look at the same sort of data in a table, right? So here we've got the quantity consumed. We've got the incremental or marginal value. We've got the net value, so subtracting the cost of the visit from the willingness to pay. And then we can get the total consumer surplus by adding them up, right? So in this case, consumer surplus is maximized by consuming 3 units. If the 4th unit was consumed, that would actually decrease total surplus by 10 $10, right? So this person would want to consume 3 and stop there, not consume any further. All right. Well, we went through that a lot faster than I expected. So unfortunately, that's all I have for you today. But I can tell you where we're going from here. So the next steps are to look at the effect of insurance on demand. And to think about this, let me go back to, where is it? Here we go. Let's come back to here, right? So the way that we derived the demand curve was by changing the price of medical care, right? Of course, at this point, we were ignoring insurance, right? We're assuming that everybody pays out of pocket everything. But what is the effect of insurance on price? What does insurance do to the price of medical care? We've talked about it before. Insurance does what to the price of medical care for a consumer?
Makes it go down.
It makes it go down, exactly. And so we would have something even more extreme than this, right? Because here we saw a decrease in the price of medical care. Well, it would go down even further, right? So that's basically what we're going to be thinking about, is how insurance affects the price of medical care and how that translates into a change or a different demand, essentially, right? A different demand curve. And there's lots of ways that insurance can affect price, right? Because there's lots of different aspects of insurance. There's co-payments, there are deductibles, all kinds of stuff, right? So primarily deductibles and co-insurance, but there are other things too that we have to think about as well. So that's what we'll be looking at on Monday, and we will wrap up this chapter by looking at how insurance affects the demand for medical care. And then on Monday, that'll be the end of the material for exam 1. So Monday we will be done with material that's on exam 1, and we will begin new material that will be on the second exam later in the semester. So, all right. Any questions about anything? All right, cool. So this is this is pretty extensive micro theory. So if you followed along and you felt good about it, you should pat yourself on the back, because this is pretty high level stuff. The only way that we can make this any harder is by starting to include some calculus, but we won't go there, fortunately for you. But yeah, if you followed along, feel good about yourself. If not, take the time to make sure you feel comfortable with this stuff. It was pretty. It's a pretty heavy load. So yeah, if there's no questions though, we can go ahead and wrap this up, and I'll see you guys on Monday. Have a good day. Stay warm out there.